Okay, and thank you very much for the wonderful introduction. So the first slide I don't even have to go through, but that's who I am. Nicholas already told you, and I'm going to give you a brief overview about BIM-based building permits in Estonia. But before going to BIM, I would start with just this kind of like digital building permit. We call it like building registry, which also can be meant like building logbook, which is a digital database of the built environment. But in addition to having all the buildings data there, actually we also have this kind of like procedural environment embedded in the building registry, so that starting from 2016, all building permit process has been 100% digital. Of course, it's PDF based. So when we say digital, it's like digital paper, but at least applicants don't have to go to the local municipality with printed construction design documents anymore. And it's a central system that is used by all 79 municipalities in Estonia. And if the applicant is not able to use the building registry, they still can go to the local government with paper documents. They have this possibility, and then the municipality will put it into the building registry. But this is very, very rarely used. We have perhaps one case per several years in Estonia for that. And in the building registry, over 32,000 procedures handled yearly, and it's a part of e-construction platform. But today I will mostly focus on the BIM-based building permits and will not go very much further on the e-construction platform. And when we're looking at this kind of like digital building permit, then this is this kind of digital container, which is digitally signed. And inside there, of course, is a PDF document, which is a building permit, which is a package of these kind of files. But then going to the BIM-based building permit process, we were thinking that BIM is in the industry already like business as usual. But unfortunately, all the processes done by the public sector, so the building permit, certificate of occupancy, demolition permit, all these kind of permits, you have to take the 2D information out from the BIM, and this kind of like rich information inside the BIM model is not used. So in 2019, we were starting with a proof of concept, so what the BIM-based permit would look like. In 2021, we developed the first version that I would call not this kind of like solid solution or mature solution, but this kind of like MVP, the minimum viable product to get this kind of BIM-based building permits going. And at the moment, we are at the final steps of integrating it with the existing process into the building registry. And tomorrow I will have the first pilot with the city of Tallinn, so that with the real-time users, how the processors and building permit specialists can do their tasks in the new environment. And of course, there are like 4 keywords with this BIM-based permit process. Of course, transparency, so that the applicants would know what is happening in the process phase. Also, because we're doing this kind of automated checks, then there would be faster review. With some checks, we can increase the quality when we're really looking at the 3-dimensional information flow instead of 2D PDF. And what was one of the main pillars for us, that it would be web-based and very simple user interface. Because even if the applicants are BIM specialists who have, for example, composed the models like architects, engineers, and BIM is part of their everyday life from 9 to 5 or even later, then the permit processors have been for decades already used to 2D drawings, and they are not using BIM in their everyday life. And having this kind of extremely sophisticated checking engine, and it would be separately and not web-based, then they would need very powerful hardware, quite costly and hard to learn software, and the skills, the tremendous training of the skill sets to use that software. So this is why we made it quite simple and integrated into the building registry, so that it would be understandable. And here are some screenshots from the automated checks, but I will also talk about it a little later on. And as a recognition of this process, the Building Smart was giving the category of Technology Award winner for Future Insight, which was our partner in developing the system for us. And at the moment, we are also part of the Horizon 2020 Accord project, where we are trying to find these kind of like similarities in BIM-based building permit internationally, so that we wouldn't invent a wheel in every country, so that we could combine our know-how and come up with this kind of like as generic process as it could be, because every country still has their differences. But before, on the last slide also, what I had written, but I didn't mention that all the models, of course, we are using also OpenBIM, the IFC, which are uploaded, they have to meet the BIM requirements, so that if we have some automated checks built in, then it's very important to have this kind of like certain set of requirements, so that we're not training the check engine to find any kind of information, but very specific kind of information. And we started with the Common BIM Requirements project already a few years ago, and now it is public. It consolidates Estonian best BIM practice, because before the Common BIM Requirements, we had the BIM requirements from the State Real Estate Agency, from Tallinn Harbor, from the Road Department, and some other state agencies. And they were always demanding basically the same things, but in a different coverage. So we were thinking that we should unify them under one umbrella and call them Common BIM requirements. At the moment, I will show on the next slides how they are in Excel, but we are looking very much into the information delivery specification, so the IDS, to make them machine readable and much more easily integratable with the different softwares. And what also to focus on is that these BIM requirements are not only for the buildings, but also for the infrastructure. So all the utility networks outside of the building, also the roads and the landscape architecture, etc. This is what at the moment these kind of like BIM requirements look like. 51 tables in Excel are for the buildings, and there are about 40 tables in Excel format for the infrastructure at the moment. So for the number one, we have here the discipline, like architecture, structure, etc. Then we have this kind of like user-defined property set. For example, here it is architectural flooring coverage. Then there are attributes that have to be there for this type of entity. Also, how it is related with the IFC, so the IFC property set, the reference, and the data type. And then there is like an example, so that, for example, under the name, there is like wooden surface. Also, what is the more exact material. Also, the finish would be like it is oiled, the garage area, etc. And on this column on the 7th, from ES to the TE, there is this kind of like explanation on which project stage you have to present this information, so that the ES is the sketch and the TE would be as built BIM model. And for example, for the building permit, we are using EP, so that would be preliminary project. And as you can see that this kind of like floor finishing element, at the moment at least, we don't have to have that kind of information presented for the building permit checks. And also there is the explanation what type of information to put here. Also, there are some examples now for the IFC building. For example, these light green ones were already on the Common BIM requirements, and the orange ones were also there. And the orange and yellow ones at the moment are these what are extremely important information for the BIM-based automated checks. And the yellow ones were not existing in the BIM requirements, and these we added from the ministry side only to have the information to make these automated checks. For example, for the IFC building, we don't have to have the name or the address of the building for the building type at the moment. We need the height of the building, also the depth of the building, the site coverage, and also the number of the users. The occupancy type would be the usage type of the building, also the specific heat load for the fire safety, and also the fire safety class, so that we could have this trigger mechanism for the fire safety checks. Also for the IFC space element, we mainly had the information that we needed, but also because we don't only want to do these kind of like automated rule-based checks for the regulations, but we also want to extract the information from the BIM model into the building permit application. Therefore, we also need to know how much of the heated area we have in the building, how much of that heated area is the area with the room temperature, and also the numbers of the residential spaces and non-residential spaces. So, for example, the apartments and restaurants and so on, so that we can extract that information into the building permit application and therefore save quite many hours of the manual inserted time. But of course, there are some challenges on the way. It wasn't extremely easy ride. There are software challenges. So that when we are using the IFC, the native formats, of course, Revit, Archicad, Tekla, Cadmatic, Magicad, etc., they are IFC certified, but they are not able to export all the necessary data according to the IFC standard into the IFC format that we were facing quite many times, that some information that we require and should be possible by the IFC standard, some softwares are not meeting these requirements. And therefore, we have to have this kind of like decision, should we make our requirements per the minimum capable software or the maximum capable software? How would it affect the market, and what should be the government position on that? A lot of discussing. Also the BIM requirements that I showed you, like 51 Excel tables for the attributes that have to be inserted, but still not all the data is there to check it against the building code, because in the first edition we automated 47 checks. So, but we have more than 30 or 40 regulations, so we still have to continue the updating of the BIM requirements, because when we want to add the new checks, then we can find that we don't have some information under these elements that we need to make these checks. And of course, when we're checking against the legislation, which has been for, I don't know, hundreds of years written for the people to understand, there are a lot of different interpretations. There is like no machine readability, and also the renewing frequency, that when I open some kind of regulation in Estonia, then most probably it is newer than 2015 or 16, so that in the 5 to 6 years, the regulation just renews, and there are some new clauses that we have to take into the consideration. And if there is no machine readability, then we have to analyze these documents. And of course, there is the possibility of having the regulation which humans understand, but it's actually not measurable. So, for example, the railings of the stairs of kindergartens have to be strong enough to prevent falling. For the machine control, it's quite difficult to understand, so that what could fall with how much of the strength, so how much strength should these railings actually have. So it's not so direct. But actually the biggest challenge what I'm facing is the implementation. So to put the software in the hands of the everyday users, and this is going to be a big change also for the applicants, for the building permit issuers. So it's going to be a quite hard journey, and hopefully at the other side of the mountain there will be sunshine and greenery, so that when the change has been adjusted to, then they can actually see the benefits that come out from it. But of course, there has to be a lot of training, a lot of explanations, and we have to prepare ourselves for those who are not happy with this kind of change. They don't want to change. They want to have their things like it has been for all the time. But such is life. And with the implementation, what helps us the most is the collaboration between the public and the private sector, so that the public procurers would be this kind of like model client, so that the state real estate agency, who is a major developer, also the cities like Tallinn and Tartu would start demanding BIM-based building permits themselves, as an example, and then the private sector can follow. And of course, from the private sector at the moment, we are in very good collaboration with the Estonian Digital Construction Cluster, which is made mostly from the private sector. Of course, there are some representatives from universities and ministry and the city of Tallinn as well. Of course, we have to have open standards and share the knowledge. And the international cooperation, as I mentioned already, like with a project like Accord or under the Building Smarter, is the regulation information requirements, so that we could make these kind of changes together in cooperation internationally. So it's easier for us like this. So now I have a small video for you how this actually looks like, but I will see if can you see now the new screen with the model viewer?
Yes, we can.
Okay. And then it's better to show it live than just in the video environment. So this user interface is our building registry, so that there would be information about buildings, the BIM module itself, which is integrated now, the people who are on the application, also the documents where you can upload your IFC file. When IFC file is uploaded, then the BIM module appears, and we can see that this demo project actually it has been finished, so that there is the existing environment, and I will put it into the full screen, so that the people actually who are uploading the model, they have to have the proper geolocation, so that what they upload is just this kind of file. But because it has the correct geo reference, then we can get the environment from our national digital twin. We can have the buildings in LOD2, which are made by the land board with the aerial surveillance, or the LOD1 as well, which is just taken from the building registry data. And of course, there are some regular IFC tools, viewer tools, that we can just take on the building stories. We can make some measurements. We can cut the building. Of course, the environment cuts itself as well. And when we get stuck in some weird place like this, then we can just quite easily go back into the beginning. But this is not what I wanted to show you. I wanted to show some results of the automated checking. So that, of course, this is the possibility to download all the check results as a BCF file. And the view I'm showing you right now is the applicant's view, so that this application has not been sent to the permit issuer yet. So the applicant can see themselves what they have uploaded, how it looks like, what are the check results. So for example, at the moment, we have quite few of the regulations that we have checked. We have the possibility of hiding or filtering the regulation results, so that if we want to see only the negative results, then, for example, the regulation for housing, we don't have any kind of results, not any kind of warning results. But if I put green ones, then we can see that there are some checks that have been done. For example, simple area checks, so that when we're checking that every living room, bedroom, and working room have the area at least of 8 square meters. So we can check it. It says what is demanded, what is the actual surface. And if I want to know that what kind of space it actually is, we can see that, okay, this is the architectural space. And as the category says, this is a living room with the kitchen. then this goes under the check of this regulation. But of course, we have very many of the elements. We have here 81 different spaces that are meeting these check results. And instead of looking one by one, we can just have this kind of like quick show of the results, what it looks like. So if there would be some yellow or red rooms, we could just go on these results and see why it is like this. And then I will show you a little bit more complicated check than just checking the area of the space. But for example, when we are checking if the living room, or in this case apartment, is accessible via the elevator, if it is located on the 4th floor or higher from the entrance to the building. So that when I'm looking all the checks, we can see that these are all the apartments on the 4th and 5th building story, and we can see that all the entrances are on the ground floor. Therefore, only these building stories apply because there are no higher ones, and we need to define a space as an elevator shaft so that just having elevator element wouldn't give us the connectivity graph. So we have to use the space for that. And then going even more complicated from the rule-based checking, because still these kind of checks, either using the connectivity graph or not, they're still attribute-based. But then when we would check, for example, we have to check what is the stair. So we have quite a lot of checks for the stairs. So first of all, we define a stair because it is defined in our regulation, so that a stair is an element with 3 or more risers. So that here we are checking the risers. We are going through the voxel server for that. And it is determining that it has 7 risers, therefore it has to be the IFC stair. And if it would be modeled as an IFC slab or some other element, then it would give the error result. It is important because when we are looking for example, the free space above the stairs, that it would check the stair elements, and if we have already some stairs that are not modeled as stairs, then we have the error result. And here also the voxel engine, we are building these kind of like voxels until the check result is completed, so that the stairs have to have at least 2.3 meters of the free space above them. And instead of like giving the information how much free space there actually is, because at some point, if it would be outer stair, then we could go into the infinity, and it would take very much of computing power, so that we are saying how much free space there is if it doesn't meet 2.3 meters. But if it meets the requirements, we stop the calculating, because all this kind of like digital trash is still a trash, and it's not very climate friendly. So also having considered to that. And in addition there, we also want to know if there are railings for the stairs, so that we are not checking if the IFC railing element exists, but instead in the voxel server we have this digital agent running around that tries to fall down, so that for example, if here we would have this kind of like railing, but the barriers would be missing, then the IFC railing element would actually exist here, but the agent can fall down here, and if this would be missing, then this part of the stair would be colored red, and we could get an error result. And the last but not least, I would show you some fire safety checks. And of course, before I was mentioning this kind of like adding the attributes to the IFC building, because we need to activate the trigger mechanism, so that for calculating all the requirements for the fire safety, we have to know the usage type of the code, so that this is an apartment building. Also, we have to know what is the surface under the building. Also, the height of the building, the closed net area, the number of the building stories, the number of the users, and then we can start calculating, for example, the fire safety class. It has to be at least TP2. but it is TP1 which is higher, so it is okay result. And here now I will show you also some false negative results. We can see here, I will also put away the map. We can see that all this kind of will also put away the buildings, so it will be easier to follow. So that we have some red elements, that they are load-bearing elements in the model structure. Of course, it's questionable that these should they be, but still the foundation elements, they are load-bearing elements. And also the floor on the surface doesn't have to actually, all these red elements, they don't have to meet these kind of like fire safety requirements. But to root these false negatives out and get only the green result, we would have to add more attributes to the BIM requirements. And we want to have this kind of like balance, not to put too much work for the architects to comply with the BIM requirements, because they're also, a lot of these attributes are still manually inserted because it doesn't come from the software, it's not possible. And there can be some errors, and getting false negative results is much better than getting false positive results, so that when the fire safety specialist would look at this kind of result, they would just say that everything is okay, nothing to worry about. These elements, they don't have to have these fire safety requirements. And also the last check that I would show you would be the length of the evacuation route. So that, for example, something like this, we are taking so that the apartment is the exit route. So from the exit route, you have to be able to escape to the evacuation area with less than 45 meters. Of course, here it's much less, so it's 7.4 meters to the evacuation area, to the corridor. Then it is 8 meters from the corridor to the another corridor, which is another evacuation area, because it is separated with the fire safety door. And from there, it's going to be 12 meters outside from the building. Of course, these other areas are not compulsory, but it still gives the idea to the fire safety department or the client that how much there should be. And if I'm filtering out the results, we can see that, okay, there is one element again, which is red. It's an elevator shaft, but again, by just looking at it, we can say that in case of fire, no one will be using the elevator shaft. It will be anyhow not working and not possible. But again, to root it out would need another parameter for the IFC space. And we were thinking that this is not such a good idea. And I was talking about getting the data, so that, for example, at the moment, there is no data for the buildings. I will see if it works. Hopefully there is no disease of the demo at the moment. So this functioned so that all these fields here were zeros, so that we extracted the heated area, also the surface, the absolute height, the height of the building, the width, the length, the depth, the volume, these kind of numbers that are perhaps not very hard to insert by hand yourself, but still it would take some time. But actually what is most time consuming would be that we have 80 apartments here, so that there are 80 total apartments with 244 spaces, and all these parts of the buildings, they have to be inserted manually. And it takes quite a lot of time. So instead we have the spaces, we have how many rooms are there, what is the entrance floor, what is the area, heatable area with room temperature, area of balconies, area of kitchens, area of open kitchens. We can get these kind of results with just clicking one button. So, and I'm quite sure that I'm over the time already. So here I will switch back to my presentation. Just click on the video and say thank you very much for your attention. And if you have any kind of questions, then I'm happy to answer.